GRDC have funded a project with several of the farming systems groups like ourselves, so ICC, Southern Growers, IREC up at Griffith, and a couple of others, Central West, but basically coordinated by FarmLink out of Temora, to actually get us, so the farming systems groups, a bit more trained up in soil pits and what we're looking at. So I'm here as an audience member today. Sam North from New South Wales DPI, he's the expert. We picked this site deliberately because it's an interesting soil. It's had a rice history. It's very clayey, as you can see. So we'll discuss what we've got here, but also how it relates back to what the trial that we're doing and how we were trying to rip and we couldn't get very far, and this pit will explain it all, why we couldn't get very far with our ripping and that sort of thing. So it's an opportunity, A, for me to learn, but also for you to learn and for you to definitely ask questions.
I worked through, and so there's an educational exercise in what to look for when you're looking at soil in order to pick out features that you can use to assist management. So look, why are things the way they are? There are 5 things to look for that help to distinguish between different soils and their properties. First one being colour, second one being texture, which is the percentage of clay in that soil, third one being structure, fourth one being organic matter, and then the fifth one that's as easily to pick off your soil chemistry test, which you've got on the sheet there. Like, I'll lump them together, but it's your acidity, acidicity and salinity. So you won't always have the opportunity to have a backhoe to dig a pit, you know, for obvious reasons. What most people will do, they will have their deep end test. And if you're going around with your agronomist or a soil sampler when they're doing those cores, it's worthwhile doing once, or if you have a problem, to actually get a look at the soil, because those cores, you'll pull them up, you can put them out on the tray of the ute, and by looking at, as I say, colour, texture, structure, and where the organic matter and the roots are, and then you sort of relate that to your soil chemistry tests, you can get a really good idea of where the limiting layers are or what might be holding the crop back in that spot. See, while you don't need to go to dig a pit, structure is very hard to pick from a core, but you still can. You get a sense of friability and things like that, but you still can do it from a core. So we'll start with colour, and the main determinant of colour is, in a sense, the aeration status or the degree of waterlogging. And on the riverine plain here, we'll have sandhills. They're a light, they'll be yellow to a reddy colour. You'll come off the sandhill and you'll be on a loam, a transitional loam. So it'll be loam over clay, and it'll be red. It'll be coarser textured in the topsoil than it is in the subsoil. And then you'll move further off the levee and away from the sandhill to the back plain to country like this, and you'll go into grey. And the reason for that is that these soils have iron in them, and when they are predominantly wet, that iron is in a reduced state and it gives you your grey colours. And when you get lots of oxygen in those soils and they're well drained, the iron rusts, it oxidises. So if you want to remember it, you know, rust is red, red soils are oxidised, you've got oxygen in those soils. So the red soils are generally better well drained than your grey soils. So just looking at this soil now, predominantly grains in the top, and you go, well, you know, like, that's a bit of a hint, apart from the fact that we're standing in a rice bay, a bit of a hint that this soil is probably not as well drained as red country. The other determinant of colour is obviously in a surface, in an A horizon, will be organic matter, and that will give you blacks generally. Like you'll see it most noticeably on a sandhill or on the sands. You know, you've got that organic layer on top, and it'll be a darker colour, and then you'll go to more leached colours underneath. There are, and you'll see it in the bottom of this pit, it's actually mottled, and that's an indication of alternating wet and dry conditions. So you'll have conditions in the subsoil here where you'll get oxidation, but within cracks where they might have more water, it'll be greyed and glayed. Grey is not as bad as that. You've seen it in rice country, you know, like after draining, for instance, or in midwinter in some of this country, it goes that bluey grey, and that's really reduced. So it's waterlogged conditions. So you're going from red through grey to bluey grey, and it's sort of really well drained to not drained at all. Texture is your clay percent. You assess your clay percent by taking half a handful of soil, slowly wetting it up and working it. And if you can roll it into a 6mm ribbon without it cracking and get that to form a circle, that'll tell you it's a nice heavy clay. This one will be something like that. The other two fractions are sand. There's got sand, silt and clay. So sand, obviously, it's gritty. Yeah, you rub it together and you can feel it. It'll feel gritty and you'll hear it when you hold it to your ear in the wet soil. You know, you'll hear it and it'll go crack, crack, squeak, squeak. Silt. So sand is the large particles. The next size particle down is silt. Silt is like a small bit of mica, so it's flat, but it's got a large surface area, and it feels silky. It's not so sticky, but it feels smooth, like silk. All right. And you think, well, clay feels like that, but no. Clay's the next size down. It's smaller again. It's sticky. You wet it, it gets sticky. And clay also has bounce, so you wet it. To not saturated but a half wet, and like it'll have that sponginess to it. Why is that important? Again, it has to do with one, ability to hold nutrients. So it all has to do with surface area and the charge that's on that surface area. You've got coarse sand, you've got big aggregates, so they don't have much surface area for the volume that they contain, and they don't have much charge. But they're loosely packed and there's lots of air between them, so they're well drained, but they won't have a high cation exchange capacity and they won't hold nutrients. So the implications for irrigation particularly is that you need to put small amounts of water on frequently, and you need to put small amounts of nutrition on frequently. So you put a big dump on and they'll leach. You move to silts, so we're talking about our loam sort of soils. They're generally in the middle. They have good structure, they drain well, they've got a reasonable amount of surface area and charge, so they can hold reasonable nutrition, and so they're often our better soils in that mid-range. You come to light clays, heavy clays, to quite heavy clays here, 30 to 50% clay, and we've got high surface area, high charge, so they've got really high cation exchange capacity. They hold on to a lot of water, but because of that ability to be compressed, they can squash down and you can lose the air in them. So because they're fine particles, if they do squash down, you lose the ability for that soil to transmit water, and that's pretty key, and for roots to grow through it, which is we'll talk about later on. Clay is a primary determinant of structure, which is the next thing to look at. And structure is how your soil is held together. So if you think of a sand, there's no structure in it. It's amorphous. It's all the one. And as you come into that increasingly smaller particle sizes, you will get an ability for those small colloids and clay particles to stick together because of that surface area and charge, and they form aggregates. And you will have, for instance, like in the topsoil here, there's an aggregate there. It's got lots of roots through it, and you see it breaks slowly, or not slowly, it'll break with very minimal pressure into smaller and smaller aggregates. And that's really what you're wanting. You want aggregation in clays because that's how your water and your air get in there. But as you come down, we've come into a higher clay content in the subsoil. It's a bit larger. Again, you've got roots through it. It does break down with minimal pressure along those breaking planes, so that's quite good structure. You end up with something around about that size. So that's good structure there. You come down even further underneath, and it's actually quite hard to drive that pick into it. And this, not many roots, and it's actually quite hard to break apart. It's drying, so when it was wet, it was actually just a solid block. So your structure is quite critical. You can pick it from the way that the soil aggregates. What you want is structure, what you don't want is no structure. where are we up to? Organic matter. I mean, that'll be roots, is what you're looking for, and darker colours. It's pretty obvious here you've got this root mat in the cultivation layer. It's actually lighter than the soil underneath it, and that's just because we've got actually a lighter texture within the cultivation layer. So because this is a dark coloured soil anyway, we're really not getting that differentiation in the surface soil that you might get in, like in the reds or particularly in the sands, where organic matter makes a real difference to colour. I've picked that surface, and like after I've finished and taken the camera off, like I'd say come up and have a look. But you can see again where the roots have got to, and we're down here, what's that, around about 60 centimetres before we run into that layer underneath. The next thing is your major soil chemical properties: acidity, acidicity and salinity, so your EC, electrical conductivity. And on your chart, like you've got a table there, and I've highlighted in red a couple of things. The nutrition's up the top: nitrogen, phosphorus, potassium, sulphur. I won't really talk about those. But pH in this 0 to 10 centimetre layer where Damian sampled, you've got a pH of 4.5. And if you look a bit further down, also in red, I've got percentage aluminium up at 1.8%. So what happens there is your soil becomes increasingly acid, aluminium becomes soluble, it comes into soil solution and becomes available to plants, and it's toxic at levels above 5%. So you're not at crop, you can see this is a good crop, you're not at crop limiting levels as far as pH goes in this soil, but because it's such a heavy clay, because it will have a lot of what's called buffering capacity, will take a lot of lime to actually raise this soil up 1 unit of pH. So at 4.5 here, we're getting down there. We want to sustain productivity. We are leaching these soils. It's rice country. We're taking product off. And so we are actually, it's an acidifying process, farming. As a matter of course, you should be thinking about liming. A trigger point in these heavy countries, like if you think 5 in calcium chloride is not a bad thing. You don't need to do it straight away, but start factoring it into your cropping. And so your conductivity readings, they actually require a bit of interpretation based on the texture of your soil. It's not always straightforward. The easier one, if you send your soil test away, you get your EC reading in a 1 to 5 soil to water. It's in these systems, it's not an issue because we have ability, and we've all, well, in most seasons, this year in particular, we've got fresh water. We're putting on very fresh river water. And so we're able to actually leach those salts down. If you turn over the page, and you look at the graphs, it's this bottom graph here, and you'll see that EC is sort of high in the top. It's actually 0 to 20. So it's 0 to 10, 10 to 20. It's high here, and in this zone here, it actually drops right down, and then it rises in this zone here, which is above this really compacted layer. And I don't know why, but my take on it would be that this is a really impermeable layer, and we've actually had like a bit of water down here, and we've had salts maybe migrate up. And if you put rice on this, that would push those salts down. I don't know where Mike is, but it'll be how many years since this has had rice on it, and that will really get rid of it. But yeah, as I say, EC in these systems not an issue unless and until you've got a high water table, and that water table is within 1.5 to 2 metres of the surface, and then you actually don't get leaching and you get salts evaporating off the top of that water table. But we've been there and we seem to have controlled that. The other one, and probably the main thing to talk about, is acidicity. And that's best illustrated by these 4 samples of soil in the petri dish. So this is our top 0 to 10. That's 10 to 20, that's 20 to 40, and that's 40 to 60. And you'll see again, where are we? It's this top right-hand graph, and you'll see, so we've expressed acidicity as exchangeable sodium percent, so it's a percent of sodium, or sodium as a percentage of the other, of calcium and magnesium. We've got an ESP of about 8 here in the surface soil, and like normally you know, like if it's less than 5 or 6, it's supposedly not sodic. Greater than 12 to 14, we say it's highly sodic. This is 8, but looking at behaviour, and that, see the cloudiness in that, you know, we can say that, yeah, like it's at 8, it's actually affecting behaviour. It's not too bad because those aggregates have held together, but we see here in the underneath at 10 to 20, and particularly here at 20 to 40, how those aggregates have melted down, particularly here. So this one, that's what we're saying, 20 to 40. So that's 20 to 40, that's in this zone here. Whereas underneath it, we've actually got really high ESP of 23%. You go, geez, that's really sodic. But, you know, that's in here. But those aggregates aren't dispersing and they're quite stable. So the reason for that is you look at these two graphs, you've got conductivity has actually increased. And so it's possibly the salts in here giving it a flocculating effect. So even though that's an ESP of 23, because it's a higher conductivity, you might have the salts actually holding that together. These soils here, particularly this one's the most leached one, and that may be why. You know, it's got the really low electrical conductivity, it's got a relatively high ESP, and that might be why that's breaking down. So there's a correlation between the two, so you can look at your test and you go, oh yeah, that looks like fine, whatnot. But the easiest thing and the simplest thing, and you can do it at no cost, is to just do that. You've got this, you can see it quite distinctly, and when Mike put the bucket in and pulled this out, the soil actually fell away from the bottom of the root zone here, and there is a difference, there is a lighter texture. So it's a lighter, like it's got a cation exchange capacity of 14, and my rough rule of thumb is that if you've got a cation exchange capacity, you multiply it by 2 and that gives you the percentage of clay for us on the plains. So it's roughly 30% clay here, but goes up to around about 50% clay as we go down. And you can feel it, compare it to a little bit lower down, and you'll feel the difference in the stickiness. This has actually got a loam, it crumbles quite nicely. It's got a lot of organic matter in it. You can see all the roots all through it, that's holding it together. So there's a few things that make this topsoil, you know, like really nice. It's a bit of a worry that it's dispersing like that, but the note that you would keep in the back of your head is that a minimum till and maintaining organic matter is going to be a really good thing in this country. So Mike's got a cultivation layer here, like he's run the discs through here, I'm assuming, and then he's drilled into a cultivated seed bed. And it's, again, it's quite common, but there is a consequence of that. Actually, I mean, the other point I would make too is that the other effect you get when you're looking in this sort of country is you'll get a landforming effect. So, you know, when you come into blocks and when you're doing surveys and taking samples, you'll know where you've got cut and fills, and that's often, you know, a good reason to differentiate your sampling too. As a rule of thumb, you know, I'll throw it out there, you all need topsoil. You need a minimum of 5 to 7 centimetres of topsoil. Not so much in these, but you do need it. You need it in order to get reasonable establishment. Otherwise you're forever fighting that crusting battle with this sort of exposure of these sort of subsoils. So you're always topsoil. And when you're looking at stuff, as I say, bear in mind where you are in the block and whether it's cut and filled. So I don't know where we are here and I don't know how much landforming has had over it, but what you see is what you see. This hasn't got the oats on it, it's just got, well, whatever that was, ryegrass mainly. But you can see I've been able to pull that cultivated mat off, and you can see, you probably can't because I've got that in the road, but the bottom surface, and come forward if you want to have a look, you've got the bottom surface of that zone where you've got the root mat, and you've got the top surface of the B horizon. And the bottom surface of the A has got a lot of roots coming out of it, and the top surface of the B has got bugger all roots going into it. And this is a restricted layer. That actually may be, you know, like there's been a disc through there and there's been a disc through there, maybe. You can make this sort of stuff up, but you can see, I mean, and part of that polish may be the fact that you know, I'm brushing it, but I suspect not. There is a little bit of a polish on that as well. For the constraint is not so much this, it's what you do here. And what you want to do is manage these two together. And I'll just to explain that, what you've got is you've got good water entry here, but you've cultivated, and before that crop and the root mat goes through it early in the season, you know, you're coming out of autumn, you cultivated in autumn, you seed into it, and then you come into winter. And we can get wet winters, and so that can fill up. And because you've cut off the pores here, that tends to slump, and you've made this smooth surface, cut it a bit, and that doesn't drain. So you get this ponding of water on top of that because you've disrupted the connectivity between those pores. Can you operate in this system without that? I'm not sure, because part of the reason why you guys are cultivating is weed control and moisture retention on fallows. So, you know, like it's how you actually manage this within the rotational system. The solution, you know, like, is to get things growing through it and to give yourself a reasonable period too. Drying helps. You know, I look at this and I would say, you know, like an obvious thing may be to, you know, come through, you know, all the machinery, all the tines you're putting in here, probably operating at around this depth, because anything underneath that, it's going to take a fair bit of horsepower. But if you can get narrow points into that, like 2.5 to 5 centimetres, and just tickle that up underneath that without disturbing that, when that is, and that's the critical thing, is the moisture content at which you do it. And it's not the moisture content that you do it at the moment, because that's just going to smear. So the rule of thumb is that you err on the dry side when you're cultivating clays, and on the wet side when you're cultivating loams. Like if you do loams when they're too dry, they'll powder, and if you do clays too wet, they'll smear and deform. So you'll get, it'll take more horsepower, but you'll actually get a little bit of shattering. And when you get that little bit of shattering, you'll get roots growing into it. And so 1 year of roots into it, the following year, like annuals, those roots will die, but they'll leave that path open, and it'll also form a bit of a weakness for cracking as well. So the following crop, the roots will grow into that, and it builds on itself. So, I mean, as we move down, you see, look, there are cracks in here, and like you can pull out as it dries, you know, like that's just lifted out. So there are good cracks in there, they are there. And structure's not fixed, structure changes. You know, like you can build structure as well as you can destroy it. So, you know, you're going to need to cultivate to get some moisture retention. The key is when you do it within your rotation, and having a rotation and having a bit of a think and being strategic about it. Like Mark Conyers did a bit of work, so he was a soil scientist at Wagga before he retired. He had a GRDC project, because there's all this mantra about no-till, and then there's conventional till, and you get the no-till zealot sort of thing. We can't run a plough through it, we can't do this, you know, da-da-da-da. And Mark said, that's not quite right, let's have a look at it. And he found that, you know, you can cultivate a soil, and within a 12 to 18 month period you will be back to where you started. My take home point from that was that, yeah, it's 12 to 18 months. So if you're coming around every 12 months, or like even between crops every 6 months, then you don't actually get a chance to build structure. The key to structure is leaving that root mat intact. And so, you know, like you know, in a hierarchy of, you know, building organic matter, everyone's saying don't burn, but, you know, if you've got a choice between burning and cultivating in order to get your paddock clean, well then burning for me is a good way to go, because it gets rid of biomass for sure, but we actually retain that, and that's what we're looking for. Yeah. And it's the fact that, you know, like those roots are there. I mean, looking here, not all of these roots are alive. You know, like some of them, like I reckon that one's an old one, like, yeah, something like that. You know, so they hang around, and they probably hang around a bit longer in this country because it's so anaerobic. But they're there, and they do form channels for you to get stuff in. So that's that topsoil, and you know, like again, we're talking about management and a couple of constraints. But the big difference, so we've got this cultivated A horizon, we've got this structured, and you can see it here, from about here to here, and there's actually a big crack, a vertical, sort of a horizontal crack here. So there's this, we start to get into a different part of the soil from about here down. And I think if we can get as many roots in this zone as we can in that, you've improved your rooting depth and water holding by another, you know, like that's another 100%, 120%. So if we can actually get to improve this bit and improve the connectivity between those two, it's not easy. You know, like the best thing to do is just have things growing in it. But below here, you see we've had that, you know, if you look at your numbers, we're getting into ESP, you know, down here was 23%. It's probably even a bit harder down here. I'll show you the graph on there, but by trying to get the pick into this stuff, it actually, you know, like it's the bottom where we go into the brown, it's very hard. We lose structure, and you can see it, we get into this more massive soil, and we go from grey and then we go into the brown. So the restricting layer, and this makes it really good rice country, you know, we've got sodium of 23%, we've really got no structure, so to speak of. We do have roots growing into it while it's moist, so we must have air in there. But this, look, when Damo, I suppose we get to the trial a bit, Damo, you got down to 35 centimetres, something like that?
Struggling. So the trial put in with I forget what the ripper was, but basically 5 times 50 centimetre spacings, 250 horsepower plus, and it took us 3 goes to get to 32 centimetres.
Yeah.
We're just, otherwise we're going to break things. Yeah, so.
Was it pretty wet?
No, it was actually, it wasn't wet, no, it was possible.